Every atom in the body has its own history, a narrative that stretches from the universe's explosion to the formation of the first stars. Looking at our hand, we see not only flesh and bones, but also stardust, galactic debris, and traces of cataclysmic explosions left in every cell. This is not a metaphor, but a scientifically proven truth, serving as the starting point for the book, The Universe Within, A Common History of Planets and People. This work opens up a different perspective on the human body, seeing it not as an individual entity, but as a living record of the entire history of the universe. From the Big Bang, supernova explosions, and the formation of the solar system to ancient rivers and ice ages, all leaving their indelible marks in the blood, bones, and breath. Through archaeological, geological, and biological details, these narratives are connected into a unified story. Humanity did not appear suddenly, nor is it in a central position. Instead, it is the result of countless successive events, a symphony of stardust, water, rock, and atmosphere. Therefore, reading this book is not just a journey through history, but also a profound reflection on oneself. Each breath is a repetition of the atmosphere's billion-year journey, and each step connects the paths of drifting continents, thereby posing the question, if the body is a record of the universe, what is the meaning of being human? Are humans truly different or just another link in the endless chain of change? This question does not have a simple answer. Rather, it sparks an intense curiosity, forcing the reader to re-examine everything they once believed about their place in the world. This very curiosity is what gives the work its special appeal. Instead of presenting dry data, the author tells the story in evocative, image-rich language, as if staging a great drama in which we are both the audience and the characters. When the tiny tooth was found in Greenland, it was not just a piece of fossilized bone, but a doorway back to hundreds of millions of years. When a zircon grain in Australia was analyzed, it was not just a crystal, but proof that water flowed on Earth since its dawn. And when an ice core from Greenland was extracted, it was not just ice, but a climate diary recording the planet's heartbeat. Humans are at once tiny enough to vanish in the vast universe, yet grand enough to carry the entire universe within themselves. The body is stardust, but it is also the place where the universe first could contemplate itself. That is the profound meaning the book suggests and the question it leaves for each person. What will we do with the truth that we are a piece of the universe's history that is both fragile and priceless? Before entering the main review, we encourage readers to purchase and read this book to fully grasp the content. Only by reading this entire work will you truly appreciate the issues I am sharing. Please consider supporting the author. Now, let us begin the review. Between the ice and the rock of the frigid, green land, the small figures moved slowly against the clear Arctic sky. I remember that moment clearly, a long day of searching, feet heavy with mud and snow. The light reflecting off the giant ice walls making the landscape seem to expand into infinity. But then all that vastness suddenly contracted into the palm of my hand. When my eyes caught a tiny white speck on the rock, no larger than a sesame seed, I knelt close, my breath condensing into frost on the magnifying glass lens. And there, an ancient tooth had slept for over 200 million years. My companion, Ferris, after looking through the glass, stood frozen. He tossed his glove into the air and hugged me as if we had just found a priceless treasure. And in fact, we had. Not because of its material value, but because within that tiny tooth lay a crucial piece connecting us to the distant past of the first mammals. From that grain of tooth enamel, we can trace back an entire long chain of evolution and finally see our own reflection. On the stormy land of Greenland, every rock is a page, and every crack in the sedimentary layer is a memory. And we, who bow down to listen to the rock's whispers, understand that the human body is also a type of living fossil or record in bone, blood, and genes of the earthquakes, eruptions, and the times when the sea receded and mountains rose over billions of years. I once thought searching in rock was merely a job of patience, but in reality, it requires even greater imagination, because you have to see what is no longer present, the forest that once grew here, the animal that ran past, or the meteorite shower that once turned the entire land into a sea of fire. Just like when contemplating the human body, one must imagine the layers of memory that flesh holds. The middle ear was once the jawbone of an ancient reptile. Our teeth were once the tools of small creatures living intertwined among the dinosaurs. A tooth is not just a tooth, it is a window opening to the universe. To understand that, you need to learn how to read the language of the rocks, the red sandstone blocks, And the pink limestone layers in Greenland are like inscriptions on the planet's body. Just like the body, we carry the vestiges of those changes in every cell. The body and the planet are two types of time capsules, each retaining the imprint of past events. Our blood vessels reflect ancient rivers. Our heartbeats remind us of the planet's rotation around the sun. And that tooth, tiny as a speck of dust, contains the whole story of how life evolved from reptile to mammal to human. The trip to Greenland taught me one thing: no event is truly separate. Our journey is always intertwined with the journey of the Earth, the rocks, and the stars. To see that connection, one must train their eyes to recognize coherent patterns in the chaos. Once you see it, the world will no longer be the same. The night sky is not just a collection of stars, but your own past. The rock in your hand is not just a mineral, but a mirror reflecting your origin. When we realize that, our smallness no longer makes us feel insignificant. On the contrary, it becomes proof that every human being is the culmination of a massive universe. Condensed in bone, gaze, and breath, the trips to Greenland were not pleasure excursions. They were long days facing icy winds, mud, and heavy steps on land that even migratory birds hesitate to visit. To reach the promising red rock formations, we had to cross sticky, glue-like mud flats, climb snow-covered slopes, and traverse icy crevices. But science does not begin with glorious moments. It begins in the library with old geological maps with scraps of paper that seemed worthless. A discarded report by Danish geologists, picked up by chance from a pile of surplus documents, became the guide that led us to the rocks of the correct age. Within the gray lines and cold symbols of the map lay the opportunity to see a piece of the past. One decision about where to set up camp could change an entire research career. The expensive helicopter forced us to decide quickly. The ground had to be dry for pitching the tent, close to a stream for water, and far enough away to avoid Arctic bears. But most importantly, it had to be near cliffs containing signs of paleontological interest. We chose a picturesque valley with snow-covered mountains at the end of our view. But beauty can sometimes deceive. There were no rock layers there containing what we needed. Each day we had to go further, eyes strained, looking for the telltale red rock, or the characteristic fossil-bearing layer. The first 3 days brought nothing but disappointment. But then, from afar, a thin red streak, like a thread, appeared under the binoculars. To reach it, we spent hours wading through mud and climbing slopes. Finally, when we set foot there, we knew we were right. It was a sequence of cliffs full of fossilized bone fragments. The scene at that moment was unforgettable. The four of us, scientists accustomed to intense debate, suddenly transformed into children, crawling on the ground, eyes glued to every bone fragment protruding from the rock. No one spoke a word, only a heavy silence as hands touched the past. And then bone fragments were found, some as small as grains of rice, others as big as a fist. Each piece of bone seemed to whisper, "I once lived, once breathed, and now I lie here to tell you my story." The work was not just collecting bones. It was also reading the language of the surrounding rock layers. The sandstone cliffs, mudstones, and pink limestones narrated geological history, valleys that were once torn apart, as continents separated, ancient lakes that once existed and then vanished. If you look correctly, you see a pattern here almost identical to the Great Lakes in Africa today, where the Earth's crust continues to rift. This connection overwhelmed me. The fissures that opened in Greenland hundreds of millions of years ago are still continuing elsewhere, and these very upheavals also leave their mark in the human body. Not just the bones, but the blood and the heartbeat all carry the memory of the planet's tremors. That arduous journey not only taught me about fossils, it also taught me about humility. A tiny bone can force us to bend down to the ground for hours, forgetting the biting cold and the fatigue. And in that moment, we realize that our body is also just a fragment, a product of the same laws that govern the rocks. Returning to the camp, we brought back hundreds of bone fragments in the wooden crates. Pieced together, they formed the shape of a small, ancient sauropod with a long neck, flat, leaf-shaped teeth, and a compact body. Not the majestic dinosaur you often see in museums. To us, it was like treasure, for it told us that the path leading to us began with the small creatures that once lived alongside the dinosaurs. Every step in the hunt for the past is like adding a piece to a giant picture, a picture of which we are the continuation. Greenland is only one piece, but it is enough to remind us that we are not separate from the layers of rock, the rivers, or the mountain ranges. We are all written from the same manuscript. Returning to the lab, amidst the boxes of fossil bones still carrying the scent of cold earth, I realized that the search did not stop at assembling an animal that died hundreds of millions of years ago. What we were truly pursuing was finding the thread connecting the human body to the vast universe. And that thread begins not with dinosaurs or tiny mammals, but with the very atoms flowing in our blood, held taut in every muscle fiber, and vibrating in every heartbeat. Try to look at the body as a chemical formula. If you gather everything together, you have a long list. Hydrogen is most abundant, followed by oxygen, carbon, nitrogen, calcium, and phosphorus, while trace elements like zinc, copper, and iodine make up a very small part. The human body is like a piece of music written with atomic notes. The common notes ring out constantly, forming the background melody, while the rare notes only interject occasionally. But if they are missing, the music will be incomplete. The strange thing is that the second most common element in the universe, helium, is completely absent from the body. Helium is inert, dislikes combining, and does not exchange electrons with anyone. Because of this, it does not participate in the reactions of life. Conversely, oxygen and carbon are much rarer in the universe, but are sociable and ready to create countless compounds. Thanks to their gregarious nature, they become the foundation for all molecules of life, from sugars and proteins to DNA. In other words, life arose not because of the most common things, but because of elements that knew how to open up and connect. The body, when viewed from this perspective, is no different from a set of Russian dolls. Smaller particles create larger ones, and one layer embraces the next. Subatomic particles form atoms, atoms combine into molecules, molecules combine into cells, which then form tissues and organs. But if you only focus on looking at individual particles, you will never understand why the heart beats or the brain thinks. The secret lies in how the small particles connect to create something that transcends themselves. A question arises: where did those atoms come from? The answer is not in the laboratory, but in the night sky. The hydrogen in your blood is a direct product of the Big Bang 13.7 billion years ago, when immense energy burst forth and gradually cooled to form the first particles. The oxygen you breathe, the carbon in your bones and muscles, were all born in the giant furnaces of stars. When aging stars exploded in supernovae, they scattered heavier elements into space, which were then carried everywhere by cosmic winds. A portion of those fragments fell down and coalesced to form the Earth, and ultimately you. We are the children of dead stars. This sounds paradoxical, but it is accurate. Your body contains iron from the exploded core of a star, calcium from galactic dust, and zinc and copper from violent reactions no one has ever witnessed. Your existence is a testimony to the stars that died billions of years ago. Looking up at the sky, we see the Milky Way with countless bright spots. Those bright spots are not just for admiring, they are mirrors reflecting our own origin. The eyes looking far today are receiving light that originated millions of years ago. Before humanity even existed, every ray of light is a fragment of a letter sent from the distant past, only now reaching our eyes. Science, in this sense, is the art of learning to read the universe's late letters. And when we can read them, we understand that humanity's family tree extends not only to monkeys, fish, or sea worms, but reaches as far as the stars. Our family tree begins with the Big Bang, is nourished in the stellar worms, and continues to expand to all forms of life on Earth. This realization changes how we view our position. No longer the center of the universe, nor a small, abandoned entity. We are simply a link in the endless chain, a connection between stardust and stars, and between rock and flesh and bone. There is a strange truth. To understand the past, we must not only dig deep into the earth and rock, but also look up at the sky. The night sky holds secrets no less important than sedimentary layers. Life from the stars is the oldest heritage that we can directly see with our own eyes. But to read it, we need people with the patience of those who search for tiny bones in the ground, the celestial. Archaeologist Henrietta Leavitt was one of them. In the late 19th century, she sat in the Harvard Observatory laboratory day after day, focusing on glass photographic plates full of white dots. The work was so dry and tedious that many people scorned it. But it was in that monotonous repetition that Leavitt discovered a law that would permanently change how we view the universe. She noticed that stars varied in brightness cyclically. The brighter the star, the longer the period of change. From this, she gave humanity a cosmic ruler, knowing a star's true brightness and comparing it to its visible brightness. One can calculate its distance. This seemingly small idea was the key to unlocking infinity. Hubble was not prominent in the scientific community until he had the giant telescope at Mount Wilson at his disposal. He used Leavitt's ruler to measure the distance to distant nebulae. He discovered that they were not clouds of gas in the Milky Way as many thought, but independent galaxies, each containing billions of stars. And more than that, they were drifting away from us. The sky is not stationary. The universe is expanding. The significance of this discovery was shattering. Earth is just a tiny speck of dust located on the edge of a galaxy, and that galaxy is only one of countless others drifting in the cosmic sea. It made the sense of human smallness clear, but at the same time opened up a profound connection. We are not abandoned. We are a part of that grand movement. From that vast picture, let us zoom back to our small home, the solar system, more than $4.60 billion years ago. A giant cloud of gas and dust contracted under its own gravity, swirling into a spiral disk. At the center, the dense mass of material ignited into the sun. Round it, rock dust collided and merged to form the planets. Heavier materials sank closer to the center, forming the rocky planets Mercury, Venus, Earth, and Mars. The lighter fragments, drifting further away, became the giant gas masses like Jupiter and Saturn. Earth formed from those very fragments, an accumulation of stardust, cosmic rock, and minerals. Zircon grains found in Western Australia are more than 4 billion years old, proving that liquid water appeared just a few 100 million years after Earth cooled. That means the conditions for life were seeded very early on. If those dust particles had drifted elsewhere, perhaps we would not be sitting here. If a slightly larger meteorite had collided with the young Earth, perhaps this planet would have remained a dead rock. Our existence is the result of a series of lucky chances, and for that reason, when we look back, we see ourselves as the descendants of fortunate stars that exploded at the right time, sowing enough matter for a planet to form, an ocean to appear, and for a body of flesh and bone to breathe, think, and love. This perspective overturns all classical notions. Humans once thought they were the center of the universe, the ultimate goal of creation. But now we understand we are merely a product of the combination of dust and randomness, one of countless variations of cosmic matter. And it is in that humility that we find the true value of the fact that every moment of existence is a rare gift bestowed by star explosions that happened billions of years ago. So, from a fossilized tooth on the land of Greenland, we have traveled to the entire starry sky. From a speck of dust in the rock layer, we see ourselves extending to the light of the Andromeda galaxy, and that connecting thread is unbroken. It runs through the earth, water, atmosphere, and sunlight, finally stopping in our breath. We do not just stand under the sky. We are a part of the sky itself. To understand the origin of life, sometimes we need to look for tiny, seemingly insignificant things. In the arid Jack Hills region of Western Australia, ancient rock blocks mixed in hot yellow sand contain fragments of zircon crystals. At first glance, they look only like brighter than usual grains of sand, but when brought into the laboratory, they tell a story that weighs billions of years. By measuring uranium and lead isotopes, we know that zircon formed between $4 and $4.40 billion years ago. This means they are nearly as old as Earth itself, and in their crystalline structure, traces of oxygen show that when zircon was born, liquid water already existed. This is one of the most miraculous discoveries. Just a few 100 million years after this planet formed, water was flowing on the surface. And with water, the possibility for life opened up. Water is not just the liquid in the oceans. It is also the inner source within each of us. The human body is a miniature ocean. For infants, nearly $3 for the body mass is water. As years pass, we gradually dry out, but still more than half of the body mass is maintained by this liquid. It is not only in the blood, but is mainly held within every muscle, brain, and heart cell. Every chemical reaction in the body, from metabolizing sugar into energy to transmitting nerve signals, occurs in a water environment. The strange thing is that the structure of extraterrestrial water also bears traces in parallel. With the water in the body, ancient flows etched deep into the rock in Australia reflect the electrolytic flows in our blood vessels. The structure of the human head in the embryonic stage is formed from arcs, identical to the gill arch structure of our aquatic ancestors. This proves that for more than $2.70 billion years, our ancestors lived entirely in water. And that memory is still deeply imprinted in every jaw joint and in every nerve of the middle ear. Looking back at history, water is not only the substrate, but also the stage for all events. Ancient rivers carried minerals to the sea, where the first organic molecules began to meet and combine. A tiny drop of water on a mountain rock might have been the site of the first amino acid chain formation. Water itself is the great laboratory that no scientist can perfectly recreate. Without water, there is no life. But it is also thanks to water that life is always in flux. Storms and melting ice have repeatedly wiped out old biospheres, then paved the way for new forms of life. Water is a destroyer and, at the same time, a midwife. And we, every time we drink a sip of water, are actually drinking the billions of years of that very history of change. Earth is called the blue planet not only because the sea covers 70% dollar of its surface, but because water has shaped its entire appearance. Mountains are eroded into sand, valleys are deeply carved, and land is torn apart by rain and wind, and then mended. We can say that this planet is a sculpture of water, and the human body as well. Bone provides the frame, but water is the artist that molds the shape. Had it not been for the lucky early presence of water, Earth might have resembled scorching, arid Venus with its choking atmosphere, or cold Mars, with only dry riverbeds proving that water once flowed. Therefore, the existence of water on Earth is a miracle, and that miracle is imprinted in every cell of ours, from ancient Zircon to the present ocean, from the glass of water in hand to the blood in the heart all remind us that we are woven from water, and that water carries us through every generation. The most overwhelming thing when looking at Earth's history is not the eruptions or collisions, but time. Geological time is not measured in days, months, or years, but in millions and billions of years. It is not rushed. It stretches out like an endless ocean, and in it, a human lifetime is just a small ripple that vanishes. The rock layers are the greatest calendar. Every sedimentary layer is a page, and every mineral vein is a symbol. The sheer cliffs of the Grand Canyon, with every parallel line, are the Earth's enduring diary. Some layers record periods of sea level rise, some tell of millennia-long droughts, and some are filled with fossilized marine life, proving that this area was once an ocean. When looking at it, we learn how to read time without a clock, and surprisingly, our body is a similar calendar. Our bones bear the traces of reptilian ancestors, our lungs retain the signs of ancient fish, and our middle ear tells the story of amphibians. Every part is a chapter in the book of evolution, written through hundreds of millions of years of experimentation and change. Earth never stands still. Continents drift, seas change shape, and the climate fluctuates extremely. Sometimes the globe is so hot that the ice melts completely, and sometimes it is so cold that the entire planet is covered by ice several kilometers thick. In each of these stages, life was pushed to the brink of extinction and then reborn in a different form. The human body over millions of generations has retained those memories. This includes the ability to resist cold, the fever mechanism to kill bacteria, or the storing of fat to survive harsh seasons. Looking back at history, water is not only the substrate, but also the stage for all events. Ancient rivers carried minerals to the sea, where the first organic molecules began to meet and combine. A tiny drop of water on a mountain rock might have been the site of the first amino acid chain formation. Some layers record periods of sea level rise, some tell of millennia-long droughts, and some are filled with fossilized marine life, proving that this area was once an ocean. When looking at it, we learn how to read time without a clock, and surprisingly, our body is a similar calendar. Our bones bear the traces of reptilian ancestors, our lungs retain the signs of ancient fish, and our middle ear tells the story of amphibians. Every part is a chapter in the book of evolution, written through hundreds of millions of years of experimentation and change. Earth never stands still. Continents drift, seas change shape, and the climate fluctuates extremely. Sometimes the globe is so hot that the ice melts completely, and sometimes it is so cold that the entire planet is covered by ice several kilometers thick. In each of these stages, life was pushed to the brink of extinction and then reborn in a different form. The human body over millions of generations has retained those memories. This includes the ability to resist cold, the fever mechanism to kill bacteria, or the storage of fat to survive harsh seasons. The paradox is that humans are both grand beings, capable of changing the entire planet, and tiny fragments of the universe. We build cities, erect dams, manufacture airplanes, and even send probes outside the solar system. But compared to geological time, all these achievements are but a blink of an eye. Conversely, compared to the size of the universe, even Earth is just a suspended speck of dust. However, true grandeur lies not in length or mass, but in the capacity for connection. When the human brain connects billions of nerve cells, we create consciousness. When society connects millions of people, we create civilization. And when science connects rock, stars, and the body, we see the complete cosmic picture that is the only sustainable grandeur. Going through the first pages of this journey, I learned that each person is a convergence of the small and the large. Within us are atoms from distant stars, water from ancient oceans, and bones that tell a story hundreds of millions of years long. At the same time, within us is a brain large enough to recount all those things to remember, to ponder, to pass on. When I began to understand that Earth is a living body, I realized that the most bizarre thing was not in the violent earthquakes or spectacular volcanic eruptions, but in the slow yet ceaseless movement of tectonic plates. They shift beneath our feet at a speed only equal to the rate at which hair grows. But after millions of years, that very movement has separated continents, built mountains, and torn open oceans. In a NASA control room, scientists hold numbers from laser systems mounted on satellites. They do not see the continental plates with the naked eye, but the light reflected from the ground shows the undeniable truth. North America and Europe are drifting apart by about $1.50 cm per year. Australia is rushing toward Hawaii at nearly $7 centimeter per year. These seemingly small numbers are proof of the planet's heartbeat, a slow rhythm, but strong enough to shape the entire landscape. When looking at a map, I imagine Earth as a giant jigsaw puzzle, with continental blocks fitting together like North America embracing Greenland and Morocco. This coincidence is not random. The rocks and fossils on both sides of the Atlantic Ocean are so similar that it can only be explained by their once being a single mass. Before the ocean opened up about $200 million years ago, this thought gives me chills. The vast sea we see today is actually just a rift continuing to expand on the supercontinent Pangaea. Sailors and scientists together drill deep into the ocean floor, extracting sedimentary cores. Each core is a time tube, containing layers of mud, organism shells, and volcanic dust accumulated over millions of years. From those small core samples, we reconstruct the entire history of Earth's crust. When continental plates separated, when the sea narrowed, and when the climate changed. The surprise is that the movement of continents not only changed the landscape, but also created turning points for the atmosphere and evolution. When rifts opened, organic mud was buried, less decomposed by bacteria, which meant less oxygen was consumed, and gradually the air became richer in oxygen. This was not an explosive event in a moment, but an accumulation over millions of years, enough to transform the world. Without that surge in oxygen, placental mammals, with their warm-blooded lifestyle, probably could not have existed. The body maintaining a stable temperature and the brain consuming huge amounts of energy are only feasible in an atmosphere rich enough in oxygen. I realize that every time we breathe, we are receiving a gift that millions of years of geological movement have quietly prepared. I often think about this paradox. The slowest movement creates the most fundamental change. Tectonic plates drift only a few centimeters per year, but they rewrite the planet's map. Hair grows a few millimeters every day. We hardly notice. But that is the rhythm of time flowing in the body. There is a strange parallel between geology and the body. Both operate in silence, but their traces cannot be hidden. The survey trips clearly showed me that connection. Standing on the red cliffs in the Rift Valley, where the ground is still tearing apart, I felt like standing before a book still being written. The lava flowing out of the rift today is the opening chapter for an ocean that will form tens of millions of years from now. And in that lava might be hidden the seeds of changes in the atmosphere, the evolution of warm-blooded animals, and ultimately, the potential for ourselves. At times I wonder why the human body coincides so closely with geological turning points. The answer probably lies in the simple truth. We are not separate from Earth, but are its product. Every atom in us has drifted through the atmosphere, been buried in mud, and been pushed up from the depths of the earth. When we understand this, the boundary between person and planet dissolves. We do not just live on Earth, we are Earth telling its own story. Classic maps that were once only hypotheses are now proven by rock. I still remember holding a sample of basalt rock from the eastern coast of North America. Its color and mineral composition were identical to the rock sample I once picked up in Morocco. There was no mistaking it. The same type of rock, the same age. located onto continents thousands of kilometers apart. Such signs are like misplaced puzzle pieces, and when pieced together, we see the outline of a continuous continent that once existed before the Atlantic Ocean opened up. Not only rocks, but fossils also tell the same story. Ancient reptiles that once lived in both North America and Africa left bones in identical red soil layers. Fossilized pollen and ancient footprints on sedimentary rock are all consistent. There is only one explanation: the distant lands of today were once side by side in the past. To be sure, we did not stop at observations on shore. Voyages with the ship Glomar Challenger changed everything. The ship was like a floating laboratory, drilling hundreds of meters down into the ocean floor to extract sediment cores. I remember the first time seeing the drill core, a circular tube, inside which were layers of deep-sea mud, tiny organism shells, and volcanic dust. Each layer is a page in the planet's diary, showing when the ocean expanded, when it narrowed, when volcanoes erupted frequently, and when the climate changed. From this data, we could reconstruct geological history with unprecedented detail. It was no longer speculation, but direct evidence. And it is in those deep-sea mud layers that we see something more important: the gradual change of oxygen in the atmosphere as rifts tore continents apart. Dense organic mud was quickly buried under the sedimentary layers. Under normal conditions, bacteria would decompose organic matter and consume oxygen. But when buried deep, oxygen was not consumed, and gradually the concentration of oxygen in the atmosphere increased. This seemingly minor process, repeated over millions of years, created a turning point. The oxygen-rich atmosphere was sufficient to nurture a completely new type of life. Warm-blooded bodies appeared thanks to this gift. Placental mammals, with their rapid heartbeats and enormous energy demands, could only exist when the air contained enough oxygen. Their complex brains and ours are the most energy-costly structures that evolution has ever created. The brain consumes terrifying amounts of energy, but in return grants the ability to remember, learn, and imagine. Without the oxygen-rich atmosphere, all of this would only be a dream. Never realized. Thinking about this, I see that every daily breath is a contract lasting hundreds of millions of years. Between the planet and life, a rift that opened in the ancient ocean floor determined the beat of our heart today. This is both astonishing and humbling before the tight bond between the body and the earth. I also realized that these silent changes redefine the limits of life. When oxygen was low, organisms were confined to simple forms. When oxygen surged, the door opened for complex bodies, large brains, intellect, and culture. And then we, who stand on the feet, thinking about the sky, are also the final product of this chain of transformation. During those days at sea, looking at the sediment core tube on the lab table, I saw more than just mud and sand. I saw the shadow of the first placental mammal small organisms that experimented with a high-energy burning way of life. I saw the prospect of humans with large brains emerging from that long evolutionary chain. In every grain of deep-sea mud, there was a prophecy about us. There is a detail that seems minor, but shows the close link between the atmosphere and the body. Every child forming in the womb is absolutely dependent on the amount of external oxygen. The placenta acts as a sophisticated bridge, where maternal and fetal blood exchange oxygen through a thin membrane. If the oxygen concentration in the air is insufficient, this bridge collapses, and new life cannot continue. There are specific numbers that show this fragile limit. At altitudes above 15,000 feet, the oxygen concentration in the atmosphere is so low that many fetuses cannot develop normally. Medical studies have recorded this. Pregnant women living long-term at high altitudes often face higher risks. This means that today's atmosphere, rich in oxygen at sea level, is the necessary condition for placental mammals to survive and thrive. When we compare this with geological history, we see a strange parallel. Around $100 million years ago, the oxygen concentration in the atmosphere was at a level equivalent to current high-altitude conditions. If placental mammals existed then, they would have had great difficulty surviving. Only when oxygen increased due to geological upheavals, such as the rifting of continents burying organic mud, did life have enough energy to sustain such energy-costly bodies. Thus, the existence of humankind today is not only due to genes, but also to an atmosphere that was painstakingly prepared over hundreds of millions of years. Every breath we take, every beat of our heart is proof that this planet has changed to pave the way for complex life. And paradoxically, that change came from processes that seem slow, almost invisible. Yet they created the decisive conditions for the explosion of intellect. I think of this biological limit as a humble reminder. We often believe we can conquer all environments, but the truth is that we only live thanks to a thin band of oxygen surrounding the planet. Stepping outside of it, we need to carry oxygen tanks, pressure chambers, and supporting technology. The human body is a living testament to the absolute dependence on the air, a gift bestowed by the silent movements of tectonic plates hundreds of millions of years ago. From here, the story opens up a new perspective. If oxygen can decide who lives or not, then it is like the throne in a dynasty. It will change hands according to the upheaval. The throne of life on Earth is not fixed. When conditions change, the old ruler collapses and the new one emerges. This has repeated many times in history. I recall the tradition of mapping stratigraphy from the 19th century. William Smith realized that rock layers contained fossils in a specific order, an order that repeated in many places. This proves that life is not random, but follows a sequence, changing through each stage. Each rock layer is like a successive dynasty. Each fossil is a witness to the changing hands of the throne. Life on Earth is therefore like a kingdom whose king is constantly being replaced. At times giant insects were the overlords, at times reptilian dinosaurs dominated, and then placental mammals rose. No one holds the throne forever because the planet itself decides who can survive. And we, modern humans, are also just temporary occupants. When I realize that, I see that every achievement, every civilization, every technology becomes fragile because sustainability lies not in the one sitting on the throne, but in the continuous flow of planetary change. From the breath of a fetus in the womb to the extinction of the dinosaurs, all follow that law, dependent on the environment, the atmosphere, and Earth. The throne of life on Earth has never been secure. Every time I look down at a rock layer, I see not only fossils, but also the traces of lost dynasties. Each geological stratum is a chapter of history where the ruler once reigned and then vanished. And to understand why the throne changed hands, humans argued for centuries. Early in the 19th century, Georges Cuvier, an anatomist in Paris, observed strange giant skeletons that did not resemble any living species. He concluded that life had undergone great upheaval, sudden catastrophes that wiped out entire species, paving the way for others to rise. That was how he explained the absence of dinosaurs, mammoths, and many other strange species. This viewpoint was called catastrophism, but almost simultaneously in England, Charles Lyell held an opposing view. He believed that the present is the key to understanding the past. What we see today, rainstorms, erosion, and rivers are the very forces that have shaped the earth over millions of years. No need for terrible catastrophes. Given enough time, everything changes. That viewpoint, uniformitarianism, dominated geology for decades. These two perspectives were not just a scientific debate, but also reflected how we understand the throne of life. If you believe in catastrophism, history is a series of abruptly dethroned dynasties. If you believe in uniformitarianism, the throne changes hands slowly, like a gentle transition. And for many years, people thought life only changed gradually. Then, by the mid-20th century, as new evidence emerged, the balance tipped back. Unusually thick layers of iridium, giant meteorite impact craters, and dinosaur fossils located right below a layer of global ash, all pointed to one truth. $66 million years ago, a meteorite struck Earth, massacring the dinosaurs and yielding the throne to small mammals. Suddenly, Cuvier's catastrophism was revived, but this time proven by modern science. The truth turns out not to be one-sided. The history of life is an interweaving of slow change and sudden upheaval. Mountains can take millions of years to erode, but only one day for a volcano to destroy an entire region. Climate can change over long cycles, but just one meteorite is enough to turn it upside down. The throne can wobble slowly and then collapse in a flash. From this perspective, humans are no exception. We often think we are the final masters, believing that intellect and technology will hold the throne forever. But looking back at history, I see that arrogance is fragile. Dinosaurs ruled for hundreds of millions of years, much longer than the time of humans. But with just one event, all vanished. If history repeats itself, we too are just another dynasty in the thick chronicle of Earth. When I recount this, I do not feel pessimistic, but liberated by the truth. The throne belongs to no one exclusively. It is only a temporary seat for whoever fits the planet's conditions at that time. And the deeper meaning is that this constant change of rule is what creates the diversity of life. Without extinction, there would have been no room for small mammals to evolve into humans. Without collapse, there would have been no new beginning. Every time I hold a fossil, I see two layers of meaning. One is the death of the old species. The second is the seed for the new species. The throne of life is therefore not a symbol of power, but a testament to eternal rotation. And when we understand that, we know that we ourselves are sitting on that fragile seat, waiting for the day to hand it over to another. When looking at the history of Earth, I cannot help but think that this planet resembles a giant organism. It has blood vessels in its rivers, flesh in its continental crust, and a heartbeat in its day-night cycles. And most importantly, it also has fevers and chills. The climate is not as stable as we once thought, but fluctuates violently, changing the entire destiny of life. The secret lies in the carbon cycle. Imagine a volcano erupting, ash and dollar, text CO_ the gas flooding the air, warming the planet. Then, rain falls, dissolving dollar, text CO_ the dollars to form a mild acid, eroding weathered rock. Minerals are carried by rivers to the sea, where they settle and lock dollar, text CO_ the dollar away in the ocean floor. This process is slow, but in the long run, it removes dollar, text CO_ the dollar from the atmosphere, cooling the planet. This cycle is like an automatic thermostat, keeping Earth from becoming too hot for water to evaporate, and not too cold for it to freeze permanently. But this thermostat is not perfect. There are times when the balance is broken. About $40 million years ago, the planet underwent a strange event. The global climate gradually cooled, and ice began to accumulate at the poles. What caused this change? Scientists were puzzled until a bold idea emerged. The uplift of great mountain ranges may have drawn dollar, text CO_ the dollar from the atmosphere. When the Himalayas and the Tibetan Plateau rose, due to the Indian plate colliding with the Eurasian plate, the newly exposed rock was severely weathered by rain and wind. This large-scale weathering process was like a giant sponge sucking up dollar, text CO_ the dollar, causing the concentration of greenhouse gases to drop. Less dollar, text CO_ the dollar meant cooler air. And for the first time in tens of millions of years, ice clung to both poles. From then on, Earth entered another cycle, the Ice Ages, when kilometers-thick ice sheets advanced, interspersed with warmer periods. These fevers and chills shaped evolution. Many species were pushed to extinction, while others adapted and rose. Life not only reacts to climate, but is molded by it. Viewed from this angle, I see the human body as a miniature copy. When we have a fever, we raise the temperature to kill bacteria. When we shiver with cold, our muscles contract to generate heat, keeping us alive. Earth behaves the same way. It heats up and cools down as if adjusting to maintain balance. And just like in the body, fevers sometimes save lives, and sometimes push us to the brink. Thinking about the cooling turning point $40 million years ago, I see it as an event that indirectly paved the way for us. Polar ice created cycles of climate oscillation, forcing life to constantly adapt. That very pressure forged resilient bodies, calculating brains, and ultimately, humankind. If Earth had not cooled, perhaps we would not exist to tell this story. What amazes me is that these grand cycles begin with tiny raindrops, with every gust of wind eroding rock, and with rivers carrying minerals to the sea. The small details in nature accumulate over millions of years, powerful enough to change the fate of the entire biosphere. In slowness there is strength, in silence there is reverberation. When I understand the carbon cycle, I clearly see that the planet is not an immutable foundation. It resembles a living entity always in a state of oscillation. And every time Earth trembles with fever or chills, life must also change. We do not just live on Earth. We live with its fevers and chills, observing the planet going through fever and chills. I suddenly think of the tiny clocks running in every cell of mine. If Earth has cycles of hot and cold recorded by ice and volcanoes, then our body also has its own cycled secret rhythms that do not need the sun or the moon to control. Experiments on fruit flies have shown this. When scientists cut a certain gene, the flies lose the ability to keep a day-night rhythm. They fly erratically, eating and sleeping abnormally. Then, when that gene is restored, the rhythm returns. The body carries an internal clock written in genes. No wall clock is needed for a reminder. In hamsters, a mutation was found that shortens their cycle to only $20 hours instead of $24. The result is that their entire life is compressed. They sleep earlier and wake up earlier. All activities are out of sync with Earth's rotation. And in humans, Some carry similar gene variants leading to sleep disorders. They are compelled to go to bed and wake up early, unable to adjust to society. Our biological clock is both synchronized with the planet and capable of falling out of rhythm, creating differences in how we live. This makes me think of the great climate cycles. Earth is sometimes out of phase, warmer or colder than normal. The body is the same. Sometimes the clock runs faster or slower than the cosmic rhythm, but both are based on a common principle. Time is not just something measured by calendars and clock hands. It resides within the material structure, from genes to tectonic plates. Everything counts time in its own way. This parallel suggests to me that we are not separate from the planet. When I feel fatigued from lack of sleep, it is perhaps like when Earth goes through a period of climate misalignment. When I am healthy because my biological clock is stable, it is also when the planet is more stable. Individual health and global health, though different in scale, rely on rhythmic cycles. From the story of the clock in our flesh and blood, we return to the giant clock of the Greenland ice. An ice sheet nearly 6,000 feet thick lies dormant like a time archive. Beneath that pristine white layer are not just frozen water, but also air bubbles, volcanic dust, and pollen traces. All are preserved as climate records. Each meter of ice is 1 year, and each kilometer of ice is hundreds of thousands of years of history. The thought that one can drill deep down and pull up an ice tube containing air from hundreds of thousands of years ago always sends shivers down my spine. That is the only way to inhale the breath that our distant ancestors once inhaled. And in that breath, we can read the dollar, text CO_ the dollar concentration, the average temperature, and the planet's hot and cold cycles. Earth has kept its diary in ice, and we only need to open and read it. The body has a clock. The planet also has a clock. Ice records the rhythm of the planet. Genes record the rhythm of the body. When we study one, we understand the other. Life and Earth are, in essence, two instruments playing in the same symphony of time. The ice sheet covering Greenland is a giant archive, as thick as an entire mountain turned upside down. To explore it, humans once built an underground city, Camp Century, where tunnels kilometers long were drilled through the dense white layer. It was built during the Cold War with military intentions, but ultimately failed. The slowly moving ice crushed the tunnels, swallowing the sturdy structures. Ice proved stronger than any human plan. Yet from that failure came a gift. The ice cores drilled for testing became invaluable data for climate science. Inside, air bubbles contain oxygen atoms and text CO_ the molecules from hundreds of thousands of years ago. The ice became the most accurate climate diary, recording every warm and cold cycle, every large and small fluctuation. We know about the ice ages, about unusual oscillations, precisely because of these ice samples. Reading the climate traces in the ice, I see a paradox. Humans, seemingly small, have the ability to read the planet's heartbeat, and from that understanding, we reflect on ourselves. We are not outside the game, but are direct products of those climate oscillations. More than 8 million years ago, the planet's surface was almost identical to today. Continents, seas, and mountain ranges were all present, but a species with an upright gait and a large brain was still missing. Everything was just waiting for a geological and climatic event to open the door, and that door was the East African Rift. The rift zone stretches over 2,000 miles, separating continental plates, raising mountains, lowering valleys, and forming a chain of Great Lakes and arid plains. This upheaval led to drastic climate change. Some areas became deserts, some retained rainforests, and many alternated between dry and wet conditions. This fluctuating environment became intense pressure, forcing organisms to adapt or perish. It was in this context that a group of primates began experimenting with upright walking. Fossilized thigh bones in Kenya show a load-bearing structure similar to humans. A small skull fragment in Chad reveals a creature with a forehead higher than apes and different eye sockets. These initial fragile traces are enough to prove the path to humanity began with tentative steps. On the cracked earth of East Africa, upright walking was not just a change in posture. It freed the two hands, allowing for grasping and tool-making. It opened up the ability to carry food, protect the young, and later hold a stick, a stone, and then fire. From those feet placed on the ground, the whole of civilization was built. In parallel, the brain gradually grew larger. Every bit of volume increase was an evolutionary gamble, costing more energy, making birth more difficult, but in return granting memory, language, and imagination. The first creations flaking stone, making fire. Sharing food were the foundation for culture to emerge. The mother of all invention was not the tool, but the very harsh circumstances that forced us to innovate. Thinking about this, I see the entire journey from stardust, water, volcanoes, and ice ages to the upright gait of humans as a unified thread. We did not appear by chance, but are the inevitable consequence of successive geological and climatic changes. From the fever of the planet to the clock in our genes, from the blue ice to the East African desert, all have pushed humankind to this present moment. And then, when I look into a child's eyes, I see the reflection of the entire story. Every breath it takes carries oxygen from ancient volcanoes. Every drop of blood in its heart contains iron from exploded stars. Every first step it takes recapitulates the upright walk from millions of years ago. Every human being is living proof that the universe has written a long work, and we are the latest chapter. Reaching the end of this journey, we can clearly see a seamless picture, from stardust condensing into a planet, from mountains and seas transforming the climate, to the first steps of humankind in the East African Valley. Every person's body is not just a biological structure, but also an archive of the entire history of the universe. Bone, blood, and breath all are testaments to billions of years of experimentation and change. We do not just live in the universe. We are a part of it, becoming conscious of itself. I want to pause here to express my gratitude to you, who have patiently listened and accompanied me on this long journey. Without your focus and patience, these complex ideas would have been difficult to organize into a meaningful story. Your listening is the necessary condition for these pages to truly come alive. Instead of lying still on paper, I hope that after closing this book, you will let me know your thoughts. Do you resonate with how the book connects the body and the universe? Or do you feel these hypotheses need to be re-examined under a different lens? It is your comments and evaluations that will help the dialogue continue, because knowledge only truly develops when multiple perspectives shed light on it. And furthermore, I want to hear from you. Which book should I step into next? What is the work? What is the idea that you crave to delve into? Please leave suggestions so that the next book is not chosen solely by me, but is also the result of resonance between you and me. Thank you for reaching the end of this road, and I believe what remains is not just a story that has been told, but a stronger connection between you and the world you live in. Thank you for listening.